Hello, good evening. How are you? How are your studies going? At least in this class. How's it going? Today we are going to review units 3 and 4 because you need those for the test, right? And lots of material in 4, but you have a lot of time. You still have another week. I thought I'd give you some extra problems. We can work on some problems today. We can do some problems that you maybe didn't find in Moodle. As I mentioned before, you can go into the midterms and do the problems in the midterms for Unit 3, but Unit 4, you're going to find the problems of Unit 4 in the final. So I'll pull up some problems and we can work on those together as well. Okay, so let's see if we can spend a couple hours doing that and I can keep your interest. If you have any specific questions, you can also ask them now, at any point, really. If not, let's get started with this exercise. This is in Unit 3. It's towards the end. I have it on page 28, I think. Oh, and the grader says he's finishing up with the papers. I gave him a lot of things to do, so that's not completely his fault. He's doing a great job with everything he's been helping me with. So I'll get you those grades for the first test before you write the second test, anyway. So let's see who shows up. I have a sense some students are not really benefiting in general. I'm speaking in general in the undergraduate and the graduate program. Some students don't feel they're benefiting classes, but I don't think that they're flexible enough to use the resources available. I mean, at least in my classes, I think I provide substantial resources. There might be too much emphasis on a student having to organize their things, organize their study, and that can be a challenge. Also, the camaraderie with other students can be a challenge. I have the sense that students, most of my classes, the students connect in WhatsApp and they share things, but we're in November already, and those the resources and the flow of the class and what's expected of you, I think it's all in place. So if you still feel like you're floundering, please let me know so I can maybe help you organize yourself if that's what needs to be done, because the resources are abundant. You just need to work on your filter if you're having trouble. Okay, so let me see what page this is for sure, because this is 28 on my iPad, but I don't know if that's the right page. Oh, sorry. Every time I zoom out. Okay, let's see. So this is page 28. And there are 6 of you, so I'm hoping the others are watching this. I'm going to pick it up at a later point in time. And if they have questions, you can email me. Oh, what did I just write? Page 6. Page 28. you have questions, you can write me. You can also write me in the comments. I'll get the message that you put a comment on here. But anyway, email's probably better. So, have you attempted this problem? Shall I give you a couple of minutes to work this out? Working this out, you should, well, you could use Excel for all the regression type problems, but you should also be able to use your calculator. So I'm going to show you how to get the answer here with your calculator. I mean, well, everything's been pretty much given to you, the values you would determine in your calculator. All that's left is putting it together. So there's two questions after, so you have here a small data set of pairs with pairs of data. And you're told about the mean, the standard deviations here. And you have the value of x and y, and you have the standardized values. And so you have to put them together to first calculate the correlation coefficient. And then I say, then I mention, just forget about what you got in A and then calculate the equation of the line for a given correlation coefficient in case you got the first part wrong. So I'll give you a minute, give you 5 minutes to finish this. To find the page. This is Unit 3. And then when you're done, you can mention your answer to part A and B in the chat. Okay. So you guys got something? Nothing. That was more than 5 minutes, I think. Pretty sure. All right. So, what you're supposed to do is use the information given, and you could calculate the correlation coefficient R yourself with your calculator. If you remember, I taught you how to do that. Everyone has a different calculator. That's okay too. You just got to learn how to use your calculator. So let me pull up the calculator. That's not it. This one. So we're going to enter the pairs of data, pairs of observations, into the data worksheet. Now there's something already there, so I have to clear it. Second, clear work. Now the first observation is pair 2, enter down, and 17, enter down. Second one is 4, enter down, 7, enter down. Third one is 4, enter down, 7, enter down. The next one is 8, enter down, 2, enter down. And then the next pair is 2, enter down, and 7, enter down. I hope I'm doing this right. Let me know if I made a mistake. And 4 and 7, 4 and 7, and then 4 and 2. So we have 2, 17, 4, 7, 4, 7, 8, 2, 2, 7, 4, 7, 4, 7. Oh, sorry, 4, 7, 4, 2. Okay, so then we want the output. We want the results. So second stat calculates statistics. The linear regression results will be provided. So you get 7 observations. The mean is 4, which it shows in the exercise. The standard deviation of x is 2, which it shows in the exercise. This is not the sample standard deviation. This would assume that the data are representing the population observations, or the values of the population. So we don't use that one. The next one's 7. Yep, y bar is 7. Sy, yep, is 5. And we don't use this because this would have assumed that our data was not a sample, but it is a sample. Finally, we have the intercept, the slope, and the R, everything in your calculator. So I'm going to do that also manually, and then I'll do it in, I don't know if I want to do it in Excel. Okay, so nobody got it. So what were your approaches? How did you try? The people that did try, how did you calculate this, or what did you do? So you were given a table. Oops. You were given a table to calculate it manually. But there were some values missing here and here, so you just had to get those values and then carry out the steps. But it's fine. If we have our calculator results, let's put them down as a check, right? What did our calculator say? I have to go back. Our calculator said A is 13.6. I'll just leave 13.7. Sorry, I'll have to memorize. Okay, A is 13.7, B is 1.67 or 1.7 negative, and R is 0.67. Let's keep 2 decimal places. So I'll say 13.67 positive, 1.67 negative, and negative 0.67. So those are the results. So let's use the table now to compute the results manually and see that we get the same thing. Let me double check my answers. My memory. That's what we got, right? Yeah. Okay. So we need to figure this out. So what's this missing value here? This is going to be 2 minus 4 over 2. So it's negative a half. Sorry, negative 1. And then this one is 17 minus 7 divided by 5. So this one is 2. And now we carry out the last steps. So let me move this over. I don't think that's going to work. It's okay. I'll just erase it. And what's the next step? So the formula says you need to multiply those together. So I'm going to number these columns. Oh, no, maybe I better not. I should write it. So what happens is this simplifies very nicely because when you multiply negative and a 0, you get a 0, and a 0 and a 0 make a 0, and a 0, 0. So most of these become 0. But this one becomes negative 1, this one is negative 2, this is 0 and 0. So that was easy. So you sum these, and it's a very simple negative 3. And then what's the last step to get R? So R is equal, remember, to the sum. It's the average, but we divide by 1 less because we use the estimates of the point. We use X bar, Y bar here. Those are estimates. So we lose a degree of freedom. So we, rather than dividing by 7, we divide by 6. Did I do something wrong? What did I do wrong? Let me write up the formula. Oh, sorry. I'm hitting the... What did I do wrong? What did I do? Oh, this is a positive. No, that's a negative. That's a negative. Negative 3. Where R equals 1 over n minus 1. Oh, I know. No, I did everything. I did everything. Right? There's 7 observations. What'd I do? Okay, that's a 2. That's what it is. Yeah, I knew there was a mistake because I've done this many times, but not recently. So that's my mistake. -4. All right, so now it makes sense. So now, using the formula for r, this is 1 over 4, not 4, 1 over 6 times -4. So now it works. So this is 2 out of 3 negative, which is the same as -0.67. So we got the same answer. Okay, and then any questions? So we got that together. So you could have done it with the calculator and finished it. You here I asked you to do it this way. I mean, I wasn't explicit. You could have just jumped to the calculator way. But if you show me your work, you have a better chance of getting part marks. You have a chance. If you put these down and they were wrong, you would get 0. But if you wrote this and got something wrong, you would lose only a point or so out of 5, let's say. Okay, so now we did that. So r is equal to -0.67. But then I tell you to ignore that result because, you know, when I grade, I want to give you a chance. And I say, okay, in case you got that wrong, just use the number 0.3 as r. Now get the equation of the line. How do we get the equation of a line? We use the result that I taught you that's in the notes. B is equal to RSY over SX because it spells risk, right? And then R is -0.67. SY is above, what was it? What was SY? And SX. It was 2 and 5. Okay. So SY was 5. Oh, and I used the wrong R. I want to use the R that they gave me, not the one I found. Read the directions. And you get the B. So the B is 0.3 times 5 divided by 2. It's -0.75. That's right, Jasmine. You're ahead of me. Okay, so we have B. And then we have a point, right? So one result is we have the slope, and then the second result is that you have a point. The fact that this line floats between all of the points in such a way that you minimize the distance from all of the points to the line. The total distance is minimized. That means that this point, x bar, y bar, because the mean is the value closest to all the points in both directions, right? This is the same idea as it being the center of gravity in both directions. That has to lie on the line. So we're going to use this. It must fall on the line. So finally, the last step is to plug it all in. Y equals a plus bx. Let me make it bigger. Y equals a plus bx. Y would, you can plug in, oh, now I have to go back again. What's x bar, y bar? Keep on touching the space bar. What's x bar, y bar? X bar is 4 and y bar is 7. It's like a roller coaster ride. Did I say 4? Oh, we also know this. Yeah. We also know b, which we've calculated to be negative 0.75. Oh. So that's going to be negative 0.75. And I have no room. And so all that's missing, so I use 1 point. All the points that lie on the line should satisfy this equation. So that's why I can just plug in that point, which is 4, 7. And I can find this intercept. A must be 7 plus, you see what I did? 3. Nope, not 7 plus 3. 7, yeah, 7 plus. What did I do wrong? Did I do something wrong again? Tell me. The slope is negative 0.75. X is 4, B is 7, everything's fine. And then, okay, let me not skip a step because I know. Let me not skip a step because that might be the problem. So this, if you multiply 3/4 by 4, you're going to get 3. So then A is equal to 10. So our final equation of the line, this is the least squares regression line, would be y equals 10, sorry, y hat equals 10 minus 0.75x. Is that what you guys get? I just don't remember this 10. Quite strange. For some reason. Did I make any mistakes? I'm gonna make it a bit bigger so you can see it properly. Oh, R was negative, that's why. It's just 3, not negative 3. What was I doing? I was thinking of the other problem. All right. So that's a positive, and that makes more sense now. That's the result I remember. Okay, so correction. This is a positive. This is a positive. So then when I solve for A, I get 4. Make sure you understand that. That's just algebra, okay? That's not, I mean, it's going to get you the final answer, but what I'm really focused on are the steps. That's the answer I remember. Thanks. My goodness. Oh my gosh. I have to wake up. All right, so how many of you followed that in spite of my errors? How many of you out of 12 get that? You can do that. You could replicate that on your own mathematically with your calculator. How many of you can do that? Doing it manually with a table, setting up the table. I asked you to do that. Or using your calculator to get the result. Give me an idea. Okay. So if you do enough exercises, you see it's just the same sort of thing, right? Same sort of pattern. Oops, sorry, I did it again. Every time I zoom out, it affects the image. Okay, I have 4 people. Okay, so what I'm going to do is let's do a few questions from some tests, unless you have questions for me. Let's do some questions from some tests. And see how you do. So you can screenshot these questions, and you can, if you go through the midterms that I have on the website, you'll see these types of questions. Okay. Very good. So half of you know what's going on. Okay. So you want me to do that? You want me to stick with regression for a bit and do some problems? Okay. All right, let's just do these. Okay, let's see. Try this one. So take a screenshot so you have a record. We want to calculate the correlation R between two variables x and y for a sample of individuals. Which of the following conditions are necessary for R to be a meaningful measure of association? X and y are both quantitative variables. The relationship between x and y is linear. X is an explanatory variable and y is a response variable. Which ones are necessary? That's the key word. What is R? R is a measure of the direction and strength of a linear relationship between two quantitative variables. So which of these three satisfy that statement? R is a measure of the direction and strength of the linear relationship between two quantitative variables. Yeah. Okay, so most of you. So Hector's asking which document is this. This is a document of my own, but questions from this document are in the sample midterms, okay? So I don't know if this ended up being a question in one of the sample midterms, in one of the midterms that I gave you, but I have to keep some things for myself, you know. So you guys can just screenshot this and keep it printed for your records. So yes, C is the answer, I believe, because it doesn't matter if you assign in terms of calculating r, it doesn't matter if it doesn't matter if the variable one variable is assigned to x in particular and the other to y in particular. If it was the reverse, if you reverse how you assign them, it wouldn't affect the calculation of r. So it's not necessary that they be assigned in a particular way to x and y. Okay, let's see what else. Okay, let's try this one. It's a little bit larger. Okay, here's a random sample of 8 North American cities is selected. The cities with their populations are shown on the map below. Considering the following pairs measured for these cities, consider the following pairs of variables measured for these cities. So what I want you to do is tell me if this relationship is positive or negative, this one is positive or negative, and this one is positive or negative between the variables. So how can I do this? Maybe I'm going to use my lasso and move it up. All right. So as I've suggested in the past, don't look at the alternatives, figure out the answer, and then go look at the alternatives, like cover the options, because they can persuade you. They can mislead you, okay? This is where I'm from. Well, this is where my parents immigrated to, so I was born and raised there. But my parents are Italian. Yeah, Jorge. Very cold. Even though it's in the center, I mean, how do I say that? I mean, even though it's not like so north, like even of this one, it is the coldest capital city. Well, next to Quebec, but no, it's colder because like all these other cities have mountains that cut the wind, but here it's flat. It's completely flat, and there's nothing to break the wind, so it's very cold. Okay, how you doing? So what about number 1? Do you need any help with this? Are you getting it? So just take a point, take a place. Well, I don't know. Let's see for the first one. Distance from the North Pole and average January temperature. What is the relationship between where you are and your distance from the North Pole and your January temperature? How can you think about this? So think in terms of high and low. So if your distance is far or high from the North Pole, you don't need the temperatures, you're just supposed to think. So if you're here, you know, if you're here, your distance from the North Pole is smaller than if you're here, right? So what is the relationship? So that we'll call this high, and we'll call this one, no, we'll call this distance from the pole. This is higher, even though it's further, okay? So this is a higher number, or greater. Right? Remember we talked about high and low relative to the average? And this is a lower number. So when this is high, what happens to the average January temperature? Where do you go on vacation when you live in Winnipeg? So the temperature is when the distance is high, the temperature is high. You see? When the distance is low, the temperature is low. You see what I'm doing? So that is what kind of relationship? So when I say high, I don't mean geographically, I mean in number and value. So when the distance is a high value, the temperature is a high value, relatively speaking. When the distance is a low value, the temperature is a low value. So what kind of relationship is that? So yeah, you guys write that. Is that better, Marlon? Positive, Hector says. And he is right. So this is a positive relationship. Just me. Let's try the next one. We'll go back to that if you still don't get it. Let's go to the next one. Okay, distance from the equator. So we'll do Mexico and Winnipeg. You see, they're on the same, isn't that amazing? So different, but on the same latitude. We have the same time zone, but completely different climate. All right. Distance from the equator and average July temperature. So when distance is high, so this is far away, when distance is high, the July temperature is what? High or low? Let's try this one. So when distance is, so this is distance is low, the July temperature is, so is there a relationship there? So it's not so much like July temperature is July temperature is not as radically different than the winter temperature, but there's still a relationship, right? So I'll do it again. When distance is high, this is far from the equator, the average July temperature is high. When the distance from equator is low, the average July temperature is So this one is negative. So the distance from the equator is high, but the temperature is lower, right, than it would be here. That's a negative relationship. So far away, high, but the July temperature is relatively low. When you're close to the equator, the July temperature is relatively high. So they're opposites. Negative relationship. Okay, distance from the nearest ocean. This one's easy. Distance from the nearest ocean. So if you're close to the ocean, so we say low distance. Low distance, what's the population? Look at the relative population on the coast. Okay, so let's do that. When distance from the ocean is low, when x is low, y is high. In other words, when you're close to the ocean, there's lots of people. When x is high, when you're far from the ocean, there's less people. So that's low. You see, that's negative. So you are going to choose the alternative with positive, negative, negative. So take a screenshot so you guys can practice that. And the answer is E. They just showed the answers like this. Right. Okay, you got a screenshot to remind yourself? See if we can find one with calculations now. These are more thinking ones. Let me see. Let's look at this one. Try that one. How'd it go? So point A is the residual when x equals 4. Does that make sense? Point B is the predicted value of y when x equals 8. Point C is the uninfluential observation. Point D is an outlier in the y direction as its value lies out of the range of other data values. All of the above are true, which is the right answer. Yeah, they really tried to trick you here, hey? The answer is C. Very good. The other ones, when you read through them, and if you know what you're doing, you realize that there's no way you could assess, even though it looks like, yeah, it's possible, there's no way that you know what the residual, well, first of all, A is not a residual of anything, right? Residual is the distance between an observation and the line, so that's nonsensical. This is false, okay? So a point cannot be a residual. That's not what a residual is. A residual is okay, so it's the value in the y direction of the point, the observation, what like the actual observation, so the actual point that you see minus the point on the line for the same x at the same so okay. The point B is the predicted value of y when x equals 8. So when x equals 8, it looks like B is there, but I don't know if it lies on the line. There's no line here. Presumably it could be, that could be the line there, but I didn't put it down, so you don't know that. So that's also false. This is for people who are a little bit confused and haven't studied enough. Tricks them to think that they didn't study that. And they don't know which one to pick. So they end up possibly picking the wrong one. Gabrielle, but isn't when a value is so far off the rest, it could be a mistake made? But that's not what's discussed over here. Okay, let's get there in a second. Hold on, I'll answer you in a second. So point C is an influential observation. So C is way off of the line and the other values. I mean, there's these other two. This one is way off. And why do I say way off? Because the line that floats closest to all the points is probably like that one or like that. But if I add in C, if I ignore C, that is, if I add in C, what happens to that line is it would be a different line that tries to include C. So that dramatically affects the line. So we call that an influential point or influential observation. And yes, that's not part of this question, but what you do with that is you have to investigate if there's an error, some sort of error in calculation, in recording, okay. So D. Point D is an outlier in the y direction as its y value lies out of the range of other data values. What's wrong with that alternative? Because C is the correct answer. So why is it that D is false? Why is D wrong? Because of how it states D is an outlier in the Y direction as its Y value lies outside the range of other data values. Is that true? Is it an outlier in the Y? So if you look at the Y values are between here and here. So D is within there and there. What it is not in between, it's outside the range. Well, it's in the range of the X as well, I guess. But it's off the line. It's far away from the line. Let me think. Let me think for a second. Is an outlier in the Y direction as its Y value lies outside the range. That's not the reason. Because it doesn't. I guess that's it. That's all I have to say. It doesn't, it's not outside the range of values. So it said too much. Now it's not an influential point in the same way C is an influential point. Like if I don't include D, actually, yes, I guess it will be. So let's see what happens. Forget about C for now. So just forget about C. Forget about C. Just forget that for a minute. Now let's say, do what I did last time. Let me erase this. So this would be the line that floats between all of the points, including A and D. Now, if I took D away, what happens to the line? Again, it has to float between all of the points. It's going to try and include A. So it's going to move like that. So D is an influential point as well, but it's the reason they called it an outlier that's the wrong statement, okay? That's the incorrect statement. Right, so for regression, we like to use the word influential, but if you said outlier, I wouldn't be so upset. It's mostly that this is wrong. The whole statement is not correct. So this is not right either, right? They're not all true. But you guys did a great job following that. Okay, good. Next, any questions? That's it for this test. Let's get another test. So these tests, they are in the most part, they're in, I think I did most of these in the sample midterms. You see these if you go through them. Like now you can complete the sample midterms before next week. You should be able to complete them. Oh, here's a nice one. Looks familiar. Let's see, there's one back here. You know what? Let me see. Sorry, I'm just checking. Okay, there's no short answer questions on these. Okay, let's try. This one. Number 13. Then we'll try 14. Take a screenshot. A small graduate class of 3 students writes a math test. The student who finished writing the fastest got the highest score in the class. The student who finished second got the second highest score. And the student who took the longest to write the test got the lowest score. If X is the time it takes for a student to write the test and Y is the student's test score, then what can be said about the correlation R between X and Y? Okay, so this is like we were talking. When one is high, is the other high? Is that what's happening? X is the time it takes for a student to write the test. Now this is the tricky part. Oh, not you guys are not getting tricked by it. The time it takes to write the test. So the time it takes to write the test for a person who writes it with little time, so when it's low, what is their grade? Their grade is high. So low time, high grade. Those are negatives. So that's why you get B. I don't know, is it B or is it perfect? Well, we don't know the numbers, do we? We don't know the values to check if it's perfect. So we just say it's not necessarily equal to 1. -1. If we knew the numbers, like for every, if one person did with 1 minute less on his test, he did 1 point greater. If we actually knew the values, we can determine how perfect that relationship is. So low time in writing the test, but high score. So low with high, and then the reverse. High time to write the test, low score, that negative relationship. Okay, let's try the next one. This is similar. I don't want to do this one, but this is like what I gave you. Whatever, let's try it because it's a different form of it's a different presentation of the formula. So try that. Let me give you some time. Okay, we'll do one more regression. I have to do something with residuals and some calculations other than this. And then we'll do probability. For this table, all you really need is this number, right? You don't need the other numbers. So you can get that by yourself. You need this number. So you just need x minus x bar to figure out x. You have x bar. Okay, so now if you go to x, you need this one and this one, because x bar is equal to 7. So all of these values here add, well, their average is 7. All I want is this value, but it's tied to this mean, so I really need this value. I need this value too. So this one's not hard to get, is it? No, because I know this. Okay, this is like an algebra problem. Sorry. It's not just statistics, but it's okay. So let's see. So let's say x minus x bar 7 times -5 is equal to 25. So this is the way you can find x, like x1, like this first one. This is like 1, 2. If I put this in here, right? If I put the index in. Are you following me? So the first step is to solve this for x1. Maybe there's an easier way to do this that you've noticed, but that's how I get x1 is 2. So x1 would be 2. So double check that. If I take that, it's -5. Yep. I you guys doing with that? So that's that. Now that I know that the sum here, 2 and 3 and 6 and 10, 16, 17, 19, 20, 21. So 21 I'll call this x5. That's what I want to know. So the sum 21 plus x5 divided by 5, it has to be the mean, so that's 7. So that's how I can find x5. Like I said, if you have an easier way to do this, let me know. Don't be discouraged. It's just, I won't give you too many questions that require so much algebra. But this is for practice. This is fair, you know. So that's 35 equals 21 plus x5. So x5 must be what? You with me? Are you following? So you're not allowed to forget anything you learn in this class. It could come up at any moment. Don't compartmentalize and data dump information that you learn. I get 14. Does that make sense? I wouldn't know. So if that's 14, 14 plus 21 divided by 5. Yeah, it works. So this is 14. So that means this is 14. And 14 minus x bar is 7. And then I can calculate 7 times 5 is 35, which, how did I know it's 35? Oh, from the sum. Is that just a coincidence? Did I make a mistake at all? I'm getting distracted by the fact this is 35 and that's 35, but okay. That's what I get. So what have we accomplished? Okay, so all we've got now are these. Okay, so these, so how do we use these to get R? R is equal to, remember, that formula like this. Remember that. Or I rearranged this and showed you that I can take this and call it covariance and then standardize the covariance. That's what R is. So let's do that. Let's sum and then average. So let's sum these. I get 77. What do you get? So I get 77 as my sum. So that makes well, I have to get the covariance. So the covariance is equal to sum divided by n minus 1, which is 4. So that's 77 divided by 4. So the covariance is 19.25. And we don't really know what that means until we standardize it. So we divide by 5 and 4, and that means more to us. Divided by 20. And it's very, very good correlation. Now, if you look back at the numbers, you get to see that, you know, these are almost the same value. Even their standard deviations are similar. They're almost replicating values. So they're, you know, you're getting one reinforced by the other, but not just that, it's almost the same number. So that's a positive relationship, and it's close to 1. I guess I could put the 0.25 in there too. 0.9625. Final answer. Questions? Oops. So review that. If you didn't get that, let me know if you have a question right now. So the answer is C, but they're very close, you see. It's a tricky one. That's a tricky one. Okay, I want to do one more with residuals in it, so we can make some residual calculations. Did you want to take a picture of that? Sorry. Screenshot. Oh, let me circle the C. Okay, let's see this one. Leonardo da Vinci. Okay, I'll do the same thing as I did last time. I'm going to lasso the questions and make it bigger first. Well, I can't make it that bigger. So you want to know which one is false. Can you read that? Is that too small? Let me see what. Yeah, you need all this information. Okay. Let me make this one smaller and then this one bigger. I'll move this over. All right, let's just read it and then I can cover the top. So Leonardo da Vinci believed that a person's height could be predicted from their arms. In those famous pictures where he has the man in a circle, those sketches of Leonardo da Vinci. The distance measured across the back between the person's fingertips when the arms are held out straight and horizontally. The values of both variables are measured in centimeters for a sample of 8 individuals. The scatter plot is shown below with the least squares regression line. Okay, so these are the measures of so their height is 1, and they put that on the y-axis. And then the other one is their arm span, which is x. And then and here's the plot. So the question is, with the equation of the least squares regression line being this one, if you can see it, and the sample mean and sample deviations this one, which is your correct answer out of these options? How's it going? So what you're supposed to recognize is this is a very good fit. The points are very close to the line. And you're not given the R, but you expect it to be positive, close to +1. And then you're asked to try and estimate, make predictions on the line when the arm span is 170. And then when it's 195. So you have all these different things you got to plug in to double check them. Let's see if there's any way to make it easier. So 170 is here, and there's no observation, okay? There's just the line here. So it's a reasonable thing to do to try and make a prediction. And it looks like it's about 170. So that looks, doesn't look bad at all, does it? So that's what you do to see where you are on the line. A good prediction for the height of a person with an arm span of 195. Oh, that's way over here. So that's 170, 180. So 190 would be here, and 195 would be here. So what it's asking me to do is to extrapolate. So like here, and the line would extend like out here. And that's off the charts too, and then you would have to extend this chart, right? And the way you would figure that out is just plugging in. This is the line, just plug it in. Plug into the equation to find out where that is. So it's going to be, yeah, maybe 197, but is that a good idea to do that? That's very much outside the range of the values. This distance is like half of the total range, the distance of half the total range. So you shouldn't be doing that. It's not a good prediction. Okay, so B is not good. So let me see if I can write on this. So this is false. This looks true so far. So I mean, you can do it, but it's not advisable. It's not a good prediction. You shouldn't be predicting far outside off the line. And statistical packages won't even give you that extension. I'm just making it, but you see that they only fit the line around the data. They didn't extend it to a mathematical line that goes on infinitely. All right, let's look at the next one. Despite the strong linear relationship between arm span and height, we cannot conclude a causal relationship, but that's true. Remember, we're trying to find the false one, so that's okay. That's true. One individual in the sample had an arm span of 172 and a height of 177. The residual for this individual is 3.45. Let's look. So 172 was the arm span, so that's here. And I guess this is the person here, right? So that, where the red dot is, would be the predicted value, and observed would be this one, minus the predicted would be a positive, and probably if I plugged everything in, that's not a bad one. I could check it. We'll check that one later. Let's make a note. We'll verify. That's worth verifying, but probably is true. There, because I want to pick B as the false one. There are 5 positive residuals and 3 negative ones. Remember, above the line, 1, 2, 3, 4, 5 are positives because the residual, again, pay attention, residual equals observed minus y predicted. And above the line, observed is always the one we see, and it's above the line, so this will always be a positive. So these are positive residuals, and there's 1, 2, they're going to count that one as a negative residual, so that's true. So I mean, we could calculate D, but we're pretty sure the answer is F is the false one. I mean, B is the false one. Right, we're looking for false ones. But let's verify this one just for practice. One individual in the sample had an arm span of 172 and a height of 177. Okay, so this arm span, this is the X, and this is the Y observed. And what I want to find is the Y predicted. The steps are find Y predicted with the line and compute residual. Okay, so where's that equation? I gotta move this again. Is this gonna allow me to separate this? I don't think so. No, it's stuck now. Oh, I got to move it. Okay. Oh, but the letters didn't come with me. Okay. This is fun. I have some scraps there. So X was 172. And Y observed is 177. And you plug into this equation here, which I can make bigger, then it wrecks everything, so I can't do that. Okay, so then Y predicted, or Y hat, is equal to negative 8.77 plus 1.06172. Okay. What do you get? I got a different number. Okay, tell me what you get. Yeah, that's what I got. 173.55. Good. So are we finished? No, now, so that was y predicted, which was 173.55, and now you get the residual. The residual is equal to y observed minus y predicted. Y observed was 177 minus 17355, which gives you 3.5. Okay, so let's go 3.45, sure. So let's go through these again. So we said this one was false, true. This is false, this is true, true, and true. So B is the answer. Any questions? So you can dig into those for the regression problems. If you want to find more, let's do some probability problems now. Yeah, you could use the equation, but I think the point was that we could, but it's not a good idea. So we don't do it. Because remember, I drew it like, you would get that number, but it's not a good prediction. It's not a good prediction. Mathematically it works, but it's not advisable to do stuff out here way away from the data. Okay, so mathematics is a tool when you do statistics, and statistics also is a tool, but mathematics is a tool, and we bend it. Okay, we don't have a full line here. We just have the line here, so we can't use the equation out here. It's not good. That's called extrapolation, and it gives you erroneous results. So do not apply. So just because you can doesn't mean you should. Let's say it like that. Okay? Which homework, Yasmin? The RLS homework or the probability homework? Okay, let's get the probability stuff. Oh no, I gotta go out. Hiccups. Uh-oh, hiccups. I have to drink some water, excuse me. All right, so let's try this question here. There's 5 questions related to this setting. So what should you do with this information? I think I'm going to take it over to the other pages. And I'll put it here. All right, so what do you do with this? What should you do? How should you approach this? Okay, I would approach this with a Venn diagram where my circles aren't exactly to scale, it just shows the relationships between these things. So wine is going to be red and beer is going to be black. And vodka is going to be blue. So I can make this a little bit bigger. And say this is 2% here in the middle. Because they cross over here, right? So wine and beer and vodka is this here. All of those. It's 2%. The wine is 55. The beer is 40. So that leaves vodka is this. We don't have that given, but we do know that wine and beer is 22. So this is 22, but since that is 2, you can make this 20, right? You can write that down. So that's 0.2. And then what else do we know? We know that 6% by wine and vodka. Wine and vodka would be here, and it's 6, but this is already 2. So that means that must be 4. And then vodka and beer is 5. So this is 1. This must be 4 too, as well, you know? Then you're told about beer or vodka is 50%. Now that's the only one we didn't use so far. So let's use that one. I'm just double checking what I did. So this one is 40% total for the beer and 55% total for the wine. So we still have to figure out vodka, but you're told that beer or vodka is 50. So all of this is 50. So what would this be to make this and this 50? Well, it wouldn't be that big, first of all. beer and vodka. Oh, it's 5. So this is 2 and this is 3. Is that what you said? Okay, thanks. Correction. And I also am going to correct this drawing. This is really off. So I just drew something without knowing exactly what it's going to look like, but I'm going to adjust it now because there's no way it's this big. It's more like this. If it really bothers you that it's not a circle, it doesn't matter. It just needs to be a shape. So the whole thing, this and or this is 50. So this is 40. So that means this here and this here have to make 10. So if that's 4, this must be 6. Any problems with that? So that makes vodka okay, so where did I lose you? At the 40? Okay, so just, this is it. All the other ones make sense. It's just this one that doesn't make sense, I think, right? So let me erase what I did. Okay, so everything I've drawn so far, but I know that beer or vodka, so that means this black or the blue makes 50. But this is already 40, so that only leaves 10% for the rest. So if this is 40, these two pieces have to make the extra 10. Remember what or means, right? It means being here or here and not double counting the overlap. So because I know beer and vodka have to be 50, 40 and 10 make 50, so that's why this has to be 6. All right, I think we have the full drawing, so that now vodka is 6, 10, 13. Oh, don't forget this. And 2, 6, 10, 15. So vodka is 15. I should use the same color. And it's over, the total, if you added those together, is over 100%, which is fine because they overlap anyways, right? All right. Remembering this part here is 2%. Okay, so most of it was easy to do. There was just this one that you had to think a little harder. All right, so we're ready to answer the questions. We have the graphic. Unless anyone sees I made a mistake, let me know. So now it's easy to answer these questions. Well, it's easier. So what's the answer to the first one? Trying to get it even. So the answer to the first one, we already have it. We just figured it out. It's 15. Questions? What about the next one? I can't fit it. Okay, so which of the following statements are true? Okay, which of these is true? Okay, let's go through them. Okay, let's skip the independent one first. Let's go through these. W and B are mutually exclusive? No, because they overlap, so that's not true. I'm gonna mark that out. W and B are independent. Okay, what about E? So let's get rid of the mutually exclusive ones. W and vodka. So wine and vodka are mutually exclusive. So that's not true, right? Because they overlap. See, we can answer these better once we have the drawing. So now we have to figure out about the independence. So independence means that if I'm in one of them, the probability of seeing the other one doesn't change. That's the idea. So let's look at W, wine, and B, beer. If I'm in wine, where beer is 40% chance outside of wine, but if I'm in wine, what's the chance of beer? The chance of beer was 40 outside, and inside it's how much? What was this again? This is beer and wine. I need to write, so this is 22, right? Let me write that beside. So this whole thing is 22. So what you need to do, so let's tie this drawing together with our our formula, right? Our mathematical probability statements. So probability of wine and beer is equal to bothering me that it's uneven. Let's make it even. Is the probability of wine times the probability of beer given wine. So this is 22%, and the probability of wine is 55%. And what's the probability of beer given wine? So you're given, so you're in wine, and what's the chance of being in here? How do we calculate that? So whenever you see this, remember that probability of B given wine could be written as the probability of B and wine, beer and wine, over probability of wine. What you have to do is basically rescale that value. You have to divide it by the wine. You have to take 22 and divide it by 55 to find this. If it's 40%, then it's going to be the same as the probability of beer, and that means they're independent. That's the idea. So using this, you could just check. So the probability of beer given wine is 22% divided by 55%. Is it 40%? Very nice. So it turns out that this is 40%. This is just like beer being 40%. I shouldn't put a circle because then you think it's another thing. But beer is 40%. So it didn't change. The chance of someone buying beer is just as likely before they buy wine than after they buy wine. They're independent. So if I put it here, it's 40%, and this is also 40%. Okay, so W and B are independent. So I know that's true. Do I need to do the rest? Can you see the rest? We should do the rest for practice. We should do the rest for practice, shouldn't we? Okay, let's look at wine and vodka. So let's always stick with wine as our base. So the chance of vodka is 15%. Somebody buying vodka is 15%. Inside of wine, what's the chance of somebody buying vodka? So let me erase this one because that's not important right now. I want now to focus on this one. So wine and vodka is 6%, you're told. So it's 15% vodka in general. Inside of wine, what's the chance of vodka? It's 6%. So what you have to do is calculate the probability of vodka given wine, which is just probability of vodka and wine scaled by probability of wine. And you should still get vodka's probability, and then everything will be cool. So what do you get? You get 0.55. No, that's not right. You get 0.06 divided by 0.55. Does that become 15%? If so, they're independent. It probably won't because we can't have two correct answers. So 0.06 divided by 0.55 is equal to like 10.9%. Sorry, I'm trying to make room. Okay, so this is 0.11, let's say. Since the probability of V given wine is not the probability of V vodka, then they're not independent. Okay? We should have gotten 15%. Okay, so I'm not going to do the other one because we only have a half hour left. Do you get the hang of that? So that's how you check. So the answer is A. One more. With the same problem. Let's move this over. if we randomly select a customer, okay, that's a good one. If we randomly select a customer, what is the probability the customer buys only wine? What is the probability the customer only buys wine? How do you do that? Oh, I give up on making it even. So only wine. Okay, so it's 55. And then you got to take off this and this. Don't forget about that. We had all those pieces and I erased them. So it was 20, 2, and 4, right? So it was 20 and 4. So all of that together is 26, no? And that leaves just wine at 29%. I think it's D. You guys agree? Okay. What else? The other ones are not relevant. We didn't learn that stuff yet. Okay. Okay, so I'm going to change the page. I'm going to go to a new problem. Everyone's got a screenshot or something of that, or you're gonna review the video later. Okay. This is like, these are sample finals, so there's a lot of problems here. You've never seen anything like it. So don't worry too much about that. Yeah, these are much more advanced. Okay, here's one. Let's try this one. You could screenshot it. What is the U symbol? Union. Or. So probability of A or B, you can translate it, is equal to probability of A plus probability of B minus probability of A and B. Now they're independent. Another step where you write this is equal to A, it's probability, plus B and you can say minus probability of A times probability of B. Now you can put it all together and see what's missing. So you know that this one is 0.7354 and this one is 0.37 and this one, well, let's put it over. I want to work with this form of it. So this one we know is 0.37 and B we don't know. So we're going to have an expression where we know this one, we know this one, we know this one. We just have to find B. Can you guys do that? Make an expression where B is unknown. So it's going to be 0.7354 equals 0.37 plus probability of B minus 0.37 because that's A times probability of B, and then isolate for B. So where's that mathematics step? Keep it interesting. Let's call this 1 PB minus 0.37 PB. Let's fix that. So So 1 minus 0.37 is 0.63. If you did it another way, let me know. And I get E. write it again. Okay, let's see if I can do number 12 of the homework. Well, I was collecting my terms and I had to join this with this, and that's how I got that term. And then I left these together, subtracted 1 by 0.37 and got this one here. Okay, I'm going to look for the homework. I did it again. Okay, you guys got this one? I'm going to pull up the homework. That's what you did, Hector? 9 divided by 16? Why would you do that? I'm so confused. Okay. You're forgiven. It's okay. Okay, I'm gonna pull up, if you would take a screenshot. That's okay. I see, okay. Okay, I'm gonna pull up. Okay, this is gonna be the last one. What am I doing? Oh, homework. Okay, so yes, you should be doing these. These are always easier than the tests. Sometimes there's a few. Oh, okay, these are the... let's see what this is. A single toss of a balanced coin has either 0 or 1 head. Right? It's either head or tail, but they're saying no heads or 1 head rather than head or tail. Each has a probability of 1/2. What are the mean and standard deviations of the number of heads? anyone who didn't look at it, try that. Okay, so what did you come up with? If we go back to the notes, actually I'll keep you here. I'll just look at my notes and tell you where to look. Okay, so what you're supposed to do with this problem is go to the rules of means and variances, and from first principles compute the mean and the variance. And I have examples of that. See, I have it for the mean. I'm just looking if I've done a full job with the variance. I guess I have. Okay, so you just have to replicate what you see there. You have to create the probability distribution, realize it's discrete. So, so you're gonna, so this is, look at, for the mean, page 36. And what they do there is you have the outcome and you have the probability. And this is in prob. Right? So the outcomes are just two. It's either 0 or 1 with a probability of half each. Half. Do you see what I'm going to do now? And then what you have to do is calculate the mean as the weighted mean. The weighted mean let me write it down. Okay, let me put it a little bit higher so I can fit in the variance. So the weighted mean is equal to, right? So you have to multiply, you have to pre-weigh the number and then add them together. It's a weighted mean. So it's 0 times 0.5 plus 1 times 0.5. So of course you get 0.5. So that's the mean. Did you get that? Did you follow that? Oh, I did a video from Moodle that links you to the YouTube videos, right, Hector? And then for variance, you have to use the other formula that you see on page I'll go with the formula's on page 39. And what you have to do, well, there's two different ways to do it, but I'll do it this way, where you have to write the formula is x minus mu. What's mu? This one is mu here, right? So we treat it like, because it's a distribution, it represents the population, we use the Greek letters and imply these are the parameters. So it's going to be deviations from the mean squared times the pi. So what you have to do is, I mean, it's confusing because it's so easy because there's just two here, but it's good practice. Good to practice with the easy one. So what you want to do is add together the deviations from the mean. Remember, the mean is mu. Ooh, that's terrible writing. Mu is equal to 0.5. So deviations from the mean for the first one, the outcome is this one. So that's the x. Let me make a note about that. This is xi, and this is the pi over here. So you take the observation 0 minus the mean, you square it, and then you multiply by the weight. And you do the same thing with the other one, 1 minus 0.5 squared, and you multiply by the weight. If you understand it, once you understand it, it feels really interesting, it's really cool. But before that, it's frustrating. What am I doing? So it's just the same formula, but you're using the formula for a discrete distribution. So then when you put this together, out of the options, it's got to be B or D, right? So let's see which one we get. Both of these are going to be 0.5 squared, which we know is 0.25 when you square it. And then you have to multiply by 0.5, and this one's also going to be 0.25 because it's going to be negative 0.5 squared, which becomes a positive. So you have basically 0.5 divided by 0.5. What is that? 0.25 times 0.5 is 0.125. So 0.125 plus 0.125, and you get 0.25. So your answers are this, and be careful because what you found is the variance doing this. This is the variance, but the question asks you for the standard deviation. The square root of 0.25 is 0.5, so that's your answer. So tricky, tricky, tricky. The answer is D. Yeah, it's tricky, right? I know, these are a little bit tricky, but keeps you on your toes. So the answer is D. Does that make sense? And look, we're on perfect time. So if you have questions in the next week, please let me know. I can pop in for some office hours. I can make a video with you, or you can ask me to make a video, and let's work like that, okay? Keep working on those problems, screenshot this, but really, you have more than enough to prepare you. So it'll be the test will be on Thursday, just like last time. Maybe I'll give you some more time, but I'd like to debrief at the end, so stick around. I'll give you 2.5 hours, and then I'll meet with you for 15 minutes or so, just to check in after the test. So with that, I can say good night. Yeah, more time is nice. Yeah, I'll just do it like that, Hector. You get to choose the problems. Good night, everyone. I've asked the TA to mail you your test, so you should get that within the day, well, 24 hours.